All right, it is May 3rd, 12:07 p.m. Welcome to CSE 340's review for the final. My edition, which usually means that I've cobbled slides together based on what I think is useful or not useful. Woohoo. So first things first, some logistics. Not everyone here is from the same section, which kind of makes it a little bit messy. But if your section is the 12 p.m. section, your final starts at 12:10, ends at 2 p.m., and that'll be tomorrow. So, good luck with that. If your section is 3 p.m. on Monday, Wednesdays, your official time slot is 2:30 to 4:20 p.m. on Friday, May 8th. If I read correctly, you can always just check the registrar. Um, Final exam schedules tend to be posted months in advance. So that's always a resource available to you. The final is offered online and in person. Um, if your final exam isn't available on Canvas yet, that's okay. As long as it's available when it's time to go, we should be fine. Um, you're allowed a one-sided cheat sheet, usually on standard US letter size paper. Um, if you want to use a bigger sheet of paper, I don't think I've ever seen a student try in recent time, but I don't know if the size is necessarily the biggest deal. Um, cool. Can I take my exam in another block? I've seen discussion about it. I don't really know, honestly, because I wasn't in that class period. Uh, I've heard a lot of things about it, but if you want to take that exam in a different block that's not your regularly scheduled assigned block, you'll probably want to email the professor to leave a paper trail. Otherwise, just plan on taking it during your assigned block. You want a time-stamped sent email to guarantee that you requested it. Uh, but that kind of brings me to my main point, which is if it's really easy and I just missed that and you can just take it whenever, go ahead. Otherwise, it's not the end of the world. Um, I might be able to see more of that as we get closer and closer to the actual exam. Um, Especially if he releases the Canvas rendition of the test tonight. I could probably take a look to see better. But I would say the easiest way is to assume you'll take it during your scheduled block. That way you're not going to hit too many scheduling snags with other classes because there's a lot of classes that tend to stack the exam slot just because there's that many classes at ASU. So content coverage, I'm pretty sure this was in the official review. Um, but there's like roughly five true or false questions. There's a bit of lambda calculus, which I've expanded out to say you should be able to figure out OCaml and lambda extraction abstractions. You can go ahead and make them both ways. Box and circle diagrams, which historically have been the bane of all existence. A scoping question, which in my experience is a hit or miss for students, and then some memory allocation type stuff. But like I said, there was an official review. I think both the other TA and um, Professor Gordon both covered the official review. So I'm not gonna triple dip on that. I'm gonna kind of just run my own thing. I would go take a look at that though after this, if you have the time. Uh, Last week or earlier, I wrote on a napkin somewhere that the couple things that students wanted to see, including a lambda calculus question, a Henley-Miller type checking question, a couple conceptual slides, and some cheat sheet recommendations. So that will all be covered in this, in addition to just other content based on me digging around. So let's hit it. So scoping, this in every single rendition of the test I've seen in this class, scoping is something that will be covered in probably various levels of detail. So let's talk about it. We have static scoping, which is, I would call that location-based scoping. And the way I think about that is my variable defined in a current function? Yes, no, check. Yes, use that one. No, it either doesn't exist or I have to go look at global scope. That's basically it. It's pretty, there's a lot of very complex ways to describe this, but in execution, that's how it works. It's either in my current scope or it's in my global scope. That's the kind of main difference point between static scoping and dynamic scoping. Because dynamic scoping is, I like to say, sequence-based scoping. Is the variable in the sequence, yes or no? If it is in the sequence, use the most recent version. Um, no, you should probably go look at your calling function recursively, which is to say your parent function. I do have an example of kind of how that's going to work, but static scoping versus dynamic scoping, there will probably be like at least one, possibly two questions on that per exam. And that brings me a little bit to, yeah, passing types. This matters, especially for static scoping and dynamic scoping, because how you pass will kind of change, my approach and the sequence and what is and is not available to a function. That being said, there's three primary passing types, ways to pass a variable or a parameter. There's pass by value, which we covered, I think, in 240 long ago. But you're just gonna copy the value, not the memory space. So anything I do to the copy won't be reflected in my parent function. If I pass by reference, I am passing the address of the memory space, which allows me to modify and tweak explicitly the variable and memory. So any changes I make to that variable, if I've passed it by reference, will be changed across every iteration of that memory space. And then the really goofy one is pass by pointer. Um, you can pass a pointer variable by value, but that value is a memory address. So it's kind of like a hybrid to me. Um, the difference between passing by reference and passing by pointer is that if I change the value at the reference point, the value will change in the memory space. But this is the same if I dereference the pointer. But if I change the pointer value, which is an address, then I can still keep in my previous stack or function, the calling function, the parent function, the original address. So I can change the value of the pointer, and because it's passed by value, I won't change my pointer in my previous function. But if I pass by reference, no matter what I do, I'm going to adjust that value. It's a bit odd, but that's the hybrid approach. It's pass by pointer. I like to call it the hybrid approach. So basically, everything's just a form of pass by value in some capacity. It's just what gets passed and what I can change because of that pass. But this might matter. I think there might be a question that might ask you and clarify how they're passing a parameter. Um, so it's good to know just the difference between the three and the implications of that. Oh yeah. So I don't want to put this on a slide, so I've kind of curated a document that has the old question and a solution on the next page. I think I want to run through my slide deck and then I'll go approach my other document. That way I'm not flipping back and forth constantly. Kind of a late decision there, but I think it'll work better that way. Box and circle stuff. This is like unironically when I was grading it in my last class, last time I was in this block. This probably was the worst part of the exam for every student, period. And I always thought that was kind of goofy because really it's not that crazy. Doesn't have to be a bad thing. Um, a box and circle plot is literally just a way to keep track of memory and like content of memory. Uh, the memory address or location is at the box. Whatever the heck is the content is the circle. The binding is the line, which is just a funny way of saying this name is connected to this memory address. I do have an example of a box and circle plot in my other document. So example, if I create a variable integer x, it'll create a box with the name x with no contents in the circle. And assignments like x equals y will copy the contents of the circle from box y to box x, the circle contents of x. And it's going to seem a little abstract, but when I showed the example, it'll make a lot more sense. Things that I've looked around and seen actual questions on in the past is the difference between L value and R value. An L value has a location, and R value has a value. There's not really a nicer way of describing that. It's just one's a memory location, one is just a numerical value of some kind. So for example, x equals y is two variables. Variables have a memory location, so they're two L values. 6 equals 6 is two R values. They don't have a memory location associated with them. X equals 7 is an L value, an R value, where X is a variable that has a memory location. You know, one of the really goofy things is that if you do like a math operation with L values, you'll get an R value because the resulting output doesn't have a memory location. So if I did like X plus Y, my resulting output would be an R value of whatever X and Y are. So an L value, I don't know, kind of a goofy thing for me, but I like to say it's like a location value. Box and circle for an ampersand will semantically just give you the address of the L value. An asterisk will let you dereference an L value or R value of a type pointer. So an example of that is if X is an integer pointer, its value is the address of another variable Y that is type int, which contains 8. So if Y has an address, then I can assign that as a value to X, and Y would have its own contents. So basically, just a really needlessly complex way of describing pointers. If I print X, I would just get Y's address, but if I dereference X, I get the content stored at Y's memory address, which would be 8. And like I said earlier, I'll have an example, but something that they're going to ask you, possibly, maybe explicitly, maybe not, is the difference between a dangling reference and garbage. A dangling reference is memory you've allocated um, to the heap. You've deleted whatever was there. You've deallocated that, but a pointer still points to that memory space. So if I were to dereference it and call it, a smart compiler will throw 5,000 errors and tell you that you're wrong. Um, but there's a chance that whatever's there in garbage happens to be useful or fit, and then it can really start throwing some goofy results out. So, dangling reference is just a reference to something you've deleted, whereas garbage is memory you've allocated to the heap, but you didn't deallocate it later, and now you can't access that anymore. This is typically what causes a memory leak. Uh, the constant my program's holding on to this, but because it's not deallocating all of this, it's starting to just grow its memory space. And I have an example of this when I come back. I'll walk it. So some equivalency stuff, there's name equivalency if they have the same name type, int, type A. And if you have to give the same declaration to two different variables, it counts. So I have in one line of declaration, ABC is type A, then they'll all have the same internal name, which is pretty cool in my opinion. Structural equivalencies, they have the same built-in type, pointers to the same thing. Uh, Something that students get tripped up on, especially in the past, is order matters. For structural equivalency, a struct that has an int and then a float is not equivalent to a struct that has a float and an int. You know, I mean, hopefully that it's just really semantic and picky, which is kind of weird. But hey, when you start getting into more like nested structs and things, it'll make a lot more sense because even though I have the same like memory space or same allocation, it'll blow up anyway. Order matters. Has to be the same order. At least in C, technically it is structural if I remember correctly. An integer pointer and an integer like array in C is kind of just the same thing because the way an array works is that it's just a pointer with syntactic sugar, with the set iterating, like an iterator in the middle of it. They're technically the same. The head of an array is just a pointer to the start of a memory space. If I remember correctly, I'm pretty sure that that question's been asked a few times, and I want to say they're the same. At least for the next 7 days, they will be perfectly exactly structurally equivalent. If you know what I'm saying. If that question comes up, it's true. Um, I'm gonna be real with OCaml. I am not proficient with OCaml. When I took 340, we didn't have OCaml as far as like requirements. And when I taught it, we didn't teach OCaml's requirement. We were still phasing that in. But you probably should understand how to write that because when I poked around the exams and stuff, there was definitely OCaml questions. So you probably want to understand how to write an OCaml expression. You want to understand what counts as a value for OCaml. You probably want to understand the outputs for OCaml. And honest to God, Fozzie has this document that I think released in announcements that will do a better job at explaining OCaml and its nuances better than I ever could. Um, go study that. When I'm done here, I'm going to consolidate all of my materials into a packet or like a zip file. It will include those slides or that document on OCaml. So those of you who take the time to go look at that before your exam are going to praise and thank yourself in the future. Um, I know that most things with lambda eventually get converted out to functions. So if I have like a lambda expression of x, lambda y, and a plus xy, it'll kind of shape down to function x, function y, x plus y. Um, so it ends up kind of syntactically becoming using their let syntax, like let sum of x, y equal x plus y. If you want to go ahead and cluster things in OCaml, you have to use parentheses. Otherwise, it will just functionally like left bracket everything. So again, I'm not super great at OCaml, admittedly. It's not something that I'm very familiar with, but I do know that there's a resource available that explains it very well. Some funny conceptual points that you're probably going to want to know. Um, C does allow programmers to declare parameterized types. If that question comes up, it's yes. Yes, it does. Implicit versus explicit polymorphism. There may or may not be a question on your exam that mentions this. Polymorphism is just the idea of allowing entities to take multiple shapes. So for an explicit polymorphism, it's did I define the structure? It's explicit. It's a manual specification of type. You know, think specifying type. If I have to tell it, hey, use this specific version of this specific operator, or hey, this type will be defined as this, or ABC or XYZ, then that's explicit. Implicit polymorphism is the machine will infer the structure. Think if I were to do just like 1 plus 1, my machine will say, oh, that's an int and an int, and then I'll override my addition operator to be int. Or if I do like a 3.4 plus a 5.9, it'll automatically say this is a float, that's a float, which means my addition is a float. OCaml, for example, has explicit polymorphism and implicit polymorphism. Uh, I know things like some of their math operators are specific based on type. So there's an example, I'm pretty sure like addition uses just integers, but addition with a funny plus uses like float. But then it can turn around and, despite this very explicit polymorphism behavior, rapidly infer the types of 9 different variables. It's really weird. But in C and C++, sometimes you have to cast values because the inferred or the implicit polymorphism will fail out. So if I do like a double and I have the value of pi and it's like 3.14, and I try to do an integer plus a float, it's not going to just automatically convert something to an integer or convert the other variable to a float or a double. It's just going to like break itself. So it's definitely fallible, implicit, but just know that if you are doing the defining, if you are doing the specification, if you are telling the machine what to believe, it's explicit. And if you are letting the machine figure it out, it's implicit. I do have a Hindley-Milner inference type example. Uh, the Hindley-Milner will infer types that are not declared. That's the whole purpose of it. Enable static typing. I don't know what the rest of that is. I wrote that at 5 in the morning. Just know that it enables static typing. Lambda calc is goofy. I couldn't find posted anywhere the slides for lambda calculus until I went digging. So I will be including the slides for lambda calculus in my packet. What is it file? Just because I think that there's something you should have if you're being tested on it. But to keep it kind of simple, all all things are expressions in lambda calculus. An expression can just be an ID. An expression can be a lambda ID with an expression after it. It can just be two expressions next to each other, or an expression in a parenthesis. This is kind of arbitrary when you think about it on a high level, but when you actually dig into it, you'll see how that works. Um, in lambda calculus, second part, we hate ambiguity. If you're not specifying how you're behaving, things will collapse very quickly in resolution order. One of the ways we fix that is with left associativity. We just assume that we cluster things to the left. Um, Example here is if we keep adding parentheses to group by the left side, we'll end up with JK in one set of parentheses, and then we'll add another variable, parenthesis it out, another variable, parenthesis it out. Uh, that little expression of lambda ID expression will go as far right as it can. This gets a little bit funny because if you want to write more complex expressions, you actually have to brick them out by parentheses. Otherwise, that expression will just go to the end. I'll give an example of how this looks when I get to my examples. Um, the other thing that's important is binding. Variables are bound when a lambda expression with an ID matches an ID in the following expression. Again, I don't have an example of this, but specifically on binding, just know that if a variable is unbound, then it's kind of just hanging out. I have an example. Like I said, I couldn't find the slide deck for week 14 posted, so I grabbed the deck from the files. I'll hand it over. That way you guys can just look at it. I would check out currying, beta reduction, the works. There's a chance that you'll have to do any number of those things for lambda calculus. And I'll have an example of like a beta reduction process, and I'll have an example of how to identify free variables and stuff. I was asked, Josh, what do I put on my cheat sheet? I'm gonna be honest with you. If I was a very cocky and super confident person, I would load my sheet with as much OCaml nonsense as I can because I would believe that I could just remember everything else. But if any one of these things is a good idea, scoping differentiation, what's the difference between static and dynamic in the resolution? What if I don't remember all my parameter passing? A box and circle example on my cheat sheet would go hard. I'm not gonna lie to you. A little bit of polymorphism distinction. Oh yeah. The difference between just a regular recursive descent parser and a predictive recursive descent parser. Oh yeah. Anything about language, syntax, semantics is fair game. I would say I might put something on there, just an example of is this included as part of the language? For me, I might even go as far as to just have the syntax of a question, like in case I'm not super familiar with the logic symbology of like inclusion and all that. Like I said, OCaml, OCaml, OCaml. I would put a lot of OCaml on my. If I were you guys and I were taking this exam, I would have a ton of OCaml on my sheet. Because I'm not familiar with it. It's kind of abstract thing to me. I might have a little bit on memory allocation, deallocation, referencing, etc. But I think probably OCaml. My word of advice before I would decide to take my exam or before I go do my examples with you guys is breathe. Y'all, it's just an exam. It's worth 15%. If you get like 50% on this exam, you get 7% of your final grade, which means if you have like an 82% in the class already, realistically speaking, you could probably do pretty bad in this and pass. You know what I'm saying? Like you could probably do pretty bad in this exam and still be fine. You know, stress is the enemy. Stress is what makes you forget things. Pressure makes you forget things. So I would say breathe and just think about it and relax a bit. I'm assuming you guys know how to calculate grade. Being in your junior year of college and computer science, it's not that hard to take a look at the syllabus and find out what your final grade is if you don't take the final at all. I mean, that's what everyone used to do when I was in undergrad many years ago now. We just, oh, how much, if I just didn't take my final today, would I pass this course? Um, I mean, even to this day, I still do that. Most of you right now, if you did even moderately well in the homework, in the projects, in the first exam, like all of that combined is unironically 85% of your grade before the final even touches. So if you did even moderately well there, like I'm talking like getting 80% of that, you realistically need like a 10% on this exam to pass. And 340 is just one of those classes where you don't have to excel to move on. I'd rather finish it than not finish it. And like I said, I've been doing this for like a long time. I'm on my fourth year of my doctorate. I've taken almost 200 credits or something like that. I've taken a lot of tests, classes I can't remember taking anymore. It's not worth the stress. Just study, prepare, and trust that you studied. If you actually just went over homework two, the slide deck, and just the content here, you have a pretty strong shot at doing pretty well. I tried to make this as comprehensive as possible, but I can guarantee I can't get it all. So just go over it, even a couple passes, trust that you studied, and breathe and relax because I promise you it's not that deep. So before I move to examples, was there anything that we needed, or can I hit the examples? Because I'm gonna try to run these examples as fast as I can, as completely as I can. It's just that there's a lot of content. I think I got 5 examples. Cool. So this is my little example sheet. It's a bit barbaric, a little bare bones, but I think I'll get the job done. If anything, I just need to do a little bit of this to make it a little bit cleaner for you guys. I'll do that real quick. It's not gonna take me that long. Just for a little bit of sanity check on my inlines. Otherwise, it's gonna look messy. That's never fun. Boom, boom, and boom. Bar. So first one is a scoping. I can almost guarantee in most iterations of this exam, there will be some kind of question like this, where it asks you, what's a static scope? What's the output? What's the dynamic scope? What's the output? So I'll kind of go over a high level of how I'd look at this problem and how I'd solve it. And the solutions are included in the next page, basically. So if I'm looking at this and I'm trying to static scope, I'm going to see that I have a global variable J. I don't really care about my crackle. I don't care about voids. Let's just go to main. Because I don't declare another variable J, I have two options. A, panic, or B, check global. Well, I have a global, so now my global J is 1. I go to crackle. It asks me if J is less than 4. Do I have a local? No. Check the global. My global's 1. And at that point, I start keeping track. All right, what's my global J? What's my local J? What's my local J? Well, my global J is 1. So now my global J gets updated. J equals J plus 1. So now it's 2. So if I print it right now, I don't have a reference point besides my global point. So I can just 2. Then I'm going to go to bar. Int J. Well, now I have a local variable J. J is going to be 0. And then I go ahead and go deeper into bar and I get another local J. So that's going to be my most recent local. My J is 5 here. However, if I go to crackle with static scoping, when I check if J is less than 4 here, I don't have a local J. In static scoping, it's either in my function or I panic. You know what I'm saying? It's either in my scope or I'm panicking. I'm panicking, so I'm gonna go check my global. Last I checked, my global was 2. I'm gonna go ahead and add to that to get 3, and now I have a printed 3 because checking my globals. If I leave and I come back, I leave this scope immediately. I print. I'm probably, if I remember correctly, printing is 0 because my local scope is up here. I've left this little small pocket. And then if I go to crackle, I'm gonna say, oh, is it less than 4? Yes, it's 3 because again, no local variable means I check the global. Boom, my global's 3. Update to 4. Print to 4. I leave. Bar. I go to crackle again. Check my variable. Nothing here. Check my global. It's 4. I don't update it again, so I'm just gonna print 4 again. So it should be, if I remember correctly, it'll be 23044 for static. This is a great example to demonstrate the difference here because then we get to dynamic scoping and it's sequential. It is going to look, if I don't have it in my local, check the function that called me. Let me explain. I go ahead and get my global J. I update J to 1. I go into crackle. Crackle says, oh, J is less than 4. True. Because my global is here. I pull it up. I go ahead and I call it. Bang, 2. D is 2. Cool, print that. Leave crackle, go to bar. Well, now I have a local variable J. J is 0. Local variable J. J is 5. If I call crackle right now, my most recent calling scope has J equaling 5. This is what I mean by it's sequential. So I should print to 5 in my function crackle. Because I'm going to say, do I have it local? No. Who called me? Bar. Check bar scope. Oh, it's 5. So it should be like 2, 5. Then I'm going to go ahead and exit scope. Come here, print. What's my most recent scope? 0. Call crackle again. Should be 1. Because my most recent scope. So this works. It's always most recent. If I leave this scope, then my most in the sequence, recent J is going to go back to being global. Global is still 2, I think. Call it, get a value. See, 2, 5, 0, 1, 3. And see how we keep track of my scopes? There you go. Scoping in a nutshell. Static scope. It's either right here in the room with me, or I refer to the good Lord above. And dynamic scoping says it's either right here in the room with me, or I refer to the most recent iteration of it in my sequence. Hopefully that, listen, you'll have this. I'll send it to you guys. But that's scoping in a nutshell. Box and circle plots are kind of weird to me as far as like actually drawing them. You might get a question like this, you might not. Again, I was doing this kind of late last night, this morning, so let me just bunk, 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 bunk. It's small little legibility things. I don't know if you'll be asked about aliases or not. You may or may not get asked, but let's take a look at this. When I look at this, I see 1, 2, 3, 4, 4 boxes. I have 4 variables, 4 boxes, 4 circles. Right now, they're all empty. If I take this and I allocate something to it, I do a little bit of malloc, then suddenly, especially for a like B, for example, memory space X, because it's a pointer, a pointer is just a variable that holds an address. The content of my circle will be the address of the box of this new memory space, memory 1, and that circle of that new memory space will be empty. I wish I had my drawing tablet, but you'll see the final result in a minute. Same thing here with C. D should have in its circle D, and A is because it's a triple pointer, it can hold the address of a double pointer. Because it holds the address of a double pointer, it will point down to the box of memory location X. Woohoo! If you were asked to draw the box circle for A, B, C, and D, and then draw and label A pointer, B pointers, dereference A, dereference B, dereference C, I'll show you what that looks like. And then if you ask for point 2, all that changes here is I make A point to the address of dereferenced A points to the address of C. Remember, if A points to the address of B, B is a double pointer. Then if I dereference it, the content is going to be the address of B, which can point to a pointer address, which will then get updated. So you'll end up with a cascading effect of holding. And then if I triple dereference A, because you can do that, I can say, hey, whatever is at A, the address stored there, whatever is at there, dereference that. Next one, dereference, which means I've dereferenced memory location Y. Give it the value of D. And then set D to be A. So let's take a look. This is mostly accurate. I think the only thing that's wrong with it is that D should have and quotation D in it, but you'll see the point. A is a triple pointer. Its circle holds the address of B. At this very moment, B is malloc to memory 1, holds this location. C is malloc to memory location 2. Dereference C, dereference B. If I double dereference A, I'll get this funny little memory address here, this box. If I dereference C, I'll get to this memory here. And D, I can't dereference really because it's not really an address, so I can just call D. Whatever's there, D is D. After I update it and I move my dereferences, you'll see that A references memory address X, B references memory address Y, which is, hold on, C. C references the same thing here, which has D in it. Now, because remember we had this beautiful memory, and then D will hold A. The longer you look at it, the more it will start to make sense to you with the ways that you can really mess around in C and C++ or anywhere else that lets you allocate and mess with memory. It's kind of what makes it a strong language is the fact that I have all this power over my memory. Some languages don't give you as much power to just make a triple pointer and have 5 aliases to the same memory address. Aliases dereferenced A and B, they're the same, they refer to the same memory space of X. Double dereference A, dereference B and C, all points to the same memory address uh, Y. If I take a triple dereference of A, double dereference of B, or a dereference of C, I'm gonna get the same memory address or memory location of 2. See how that works? It seems complex, but really it's just pedantic is a better word. It's not really complicated. It's just they're gonna try to trip you up a little bit by having a bunch of infinite depth. But if you actually sketch it all out, kind of like this, where I have A, B, C, D, the variable names, the box that points you, then go ahead, label on the right of that the name of the memory box and the location. It won't be that bad. It's not that crazy when you really get down to brass tacks. It's literally just at every step, make sure that you've updated your little plot. Start by making box for memory address W. Then make X. Ooh. Then make X. Then make Y. Then make Z. Connect their variable names to it. Every time I make a malloc, make a new box. Every time I make a new variable, make a new box. And then when I start delving into the needlessly pedantic nonsense of dereferencing, just understand that for every dereference I do, I can hold the address of the next thing below it. And this is mostly accurate. I think I should have a D in this little circle here, but other than that, looking good. My Henley Milner example that I had. This is ripped straight off of, I think, my final exam from 2023. I have this function of f, d, e, g, h. I have an array access of h, d, e, g. Function d takes parameters e, g. I have the array g takes input array e, which takes an index value. And then I add bar to it, which is an array of characters or a string. Your call. I don't quite know what exactly they're going to do with this, but if you could understand this problem, congratulations. Most of Henley Milner's stuff is going to be really easy. So let's think about it. The way I've done it is basically kind of like left to right. The the last thing I resolve is the highest thing up, and the first thing I resolve is the farthest thing to the left and down. Makes it a little bit easy for me. So if I'm looking at the type of D, well, let's take a look. D, if I look at my funny chart that I've made, well, don't know. I can't tell based on my initial thing. Can't tell here. Have to go down further. Oh, I'm gonna get some kind of value from H and some kind of value from G. Apply D. So D is a function of type E and G. That's all it is. It takes E and G in and returns an integer. I know it returns an integer because it's acting as an index. What is E? Well, I know that E is an array of something, type nonsense. Let's say type 2. Why? Because I don't actually know what gets returned yet, because I'm not far enough up. So if I were to walk this, I would probably, before I do any of these, I just start walking it up. If I know D, don't know what that is, but I know it's a function of E and G. Okay, so I'd have to map out D, E, G, H, and I just keep updating. I know that as I go up, D has to return an integer because it's an index here. H is something. It's something. G, I know, has to return same type as H because they're going to be added up here. I know that E has to return an integer because it's going to act as an index. I know 0 is an integer index value. So I know just based on this tiny box down here, E is an array that contains integers. G is an array that contains some type. H is an array that contains that same type because they have to be added together. D is a function that returns an integer because it's going to act as a array or index. And because of that bar at the top right there, I then know that H has to return either a character or a string, and G has to return a character or a string because they all have to get added together. A function that takes an array of integers and an array of characters and returns an integer. D. An array of int, E, an array of characters, G, returns an integer. We find out just by walking through it. 2, E has to be an array of integers because it just spits out an index value. 3, G and H. Both of them are arrays of characters. Let's just assume characters. I would accept string on this as well. An array of strings. Either way would be acceptable to me on this exam rendition. And then the type of F, it returns either an array of characters or a string. Like I said, I'm a little flexible because of that string typing there, because of the array of characters. But if you want to get down to brass tacks, it's just an array of characters. But you see, I can run that pretty quick by just using a little bit of, you know, thinking, a little bit of logic. I know that indexes have to be integers. I know that types have to be the same if they're being added, subtracted. I know that if I'm resolving a Boolean type thing, I have to have a Boolean. That's kind of how Henley Milner works. It assumes that I have to have something in this space, and that tells me what I need to know. otherwise, if I don't know what it needs to be, I can assume that they need to be the same thing if they're being operated on together. If you can navigate this question here, it should, whatever other question you have for Henley Milner should be pretty easy with the exception of understanding that, the actual syntax or the breakdown of that tree for an if statement or a for loop might be a bit weird. But realistically, that's all it is. It's do I need to have them be the same thing? Yes or no? Are they the same thing? Yes or no? If they're ambiguous, now they are the same thing. If they're not ambiguous, pray they are the same thing. In my lambda calculus, I have this beautiful little awful tricky sen expression. And all I'm gonna do is parenthesize this and identify some free variables in it. Great. This is what I was talking about. It will go as far right as possible unless you bind it. Let's take a look at it. In this, you'll see that I have capped out this little expression with parentheses, meaning that this lambda ID can only go into the end of this parenthesis. But here, you'll see that I don't impose such restrictions. So it's going to go ahead and this little lambda expression will capture all of this, which also means that this little lambda expression is going to capture all of this, which means that this lambda expression is going to capture just this because it's bound by parentheses. So let's take a look. If I really get down to breaking this into parentheses, see with that left alignment, that left mentality, you'll see that first things first in that little first expression. I'll grab this so I can show you guys. The first thing I'm going to do is I'm going to say, oh yeah, all of this, all of this nonsense right here. Put it here. Just going to do a couple of these so I can show you kind of how the parentheses are going to shape down. I actually start in here, and I'm just going to do this. Because I know this is how this is going to work. Cat's here. I know I'm going to have to parenthesize it like this, or just be weird about it. That works too. Heard. And then I know that that captures like that. And then I know that this becomes a block like that with the expression. And then I'm going to actually capture this next little section. You'll see that I'm just going to start capturing things. Now I know that this is its own little expression, so I'm going to just start by saying all of this is together. Why not? Make it a little bit easier. And now I'm going to go ahead and capture this. I know that this has to be like this. It's its own like little expression in here. And then I can start breaking it down a bit. I know that these two are going to get captured like this. Add in this. And it'll slowly start building out. Capture this here. And then I know I need to capture. It's this is all it is. All it is just a bunch of Oh yes, these two cluster, these two cluster, these two cluster, these expand out, and eventually you'll capture all of it. Well, now I need to know, I need to have all of this together. Woohoo. Put all this together. And now I can go ahead and take this and see where the rest of my things capture. And which is mainly in here. First it's gonna be these two will come together. And then I'll just add these two. And then I'll add because of how the left expression works. Bada bing, bada boom. It's something like that. Minus the little bit of spacing oddity. There you go. And when I actually look at what's captured, what's free and what's bound, free just means there's no lambda ID that's going to capture it. And Y is always free because I don't have any lambda Y at all. So I can just mark every Y as free. But here, because of these parentheses and the way it's all sitting, I know my X is free. I don't have a lambda to capture that X. And because, if we look at the top here, we have a self-contained lambda Z, this Z is going to be free. But everywhere else, every other variable is captured. They're bound to an expression. But because I have free variables of X, Y, and Z in the expression, they're all going to be free variables. I'll leave this as it is. And then beta reduce. Forgive my eccentricities, but beta reduction is literally just apply something outside of parentheses into something. Did I break it down quickly? I did. Cool. So when I beta reduce, the whole point is to shrink the expression, make it smaller. So this is my breakdown. Notice how this is a self-contained expression in parentheses and all of this is in parentheses. Because of this and the breakdown, I can apply and shrink my expression. So I'm going to take this, and when I reduce, I'm going to use the first instance of a lambda and break it down. Anywhere I see an E in this expression, I'm going to replace E with this statement, with this expression, which gives us this. You'll see that E here became this. But you'll also notice that this lambda E went away. Bye-bye. Be gone. Well, that kind of works infinitely. Inside expressions, outside expressions, because of order of operations, as long as there's a lambda inside and a variable outside, I can apply left, right. So I'm actually going to take this B because it's the first one left. Farthest thing left. If I were to take this and I would shape it down, I'd put parentheses kind of like this, for example. And then I kind of take another one like this, for example. Bada bing, bada boom. And so I'd apply that B first internally. You'll see that this A, anywhere I have an A, I'm going to replace it with B. Get rid of my lambda. I get this BI. Now, because of how it looked up here, it's going to be the same thing. If I put my parentheses down, yada yada, bada bing, because they're in the same area now and they're in the same block, I can actually apply ABC. Anywhere I see an I get this exact ABC, which is going to give me this final beta reduction. Excuse me, when I talk a lot, I cough a lot because my throat gets dry. That's kind of a full beta reduction. If all of these examples make sense to you, congratulations. The exam will probably be pretty easy for you. If you need to go back and look at them, I would definitely do that because it's kind of what I imagine the exam is going to kind of look like. Because there's going to be questions like make something like this syntax tree, find types, do a box and circle plot. I'm actually going to make a little note here. D should have that's a value. Space G. There, just for my sanity. If scoping makes sense to you, my God, you're gonna have a great day. It's gonna be great. Easiest exam of your life if these examples make sense to you. Because deep down, if these examples make sense to you, then conceptually you understand the content. Now, I know I've already gone over 10, 13 minutes, but I'm hoping that despite my more laissez-faire approach to explanation, this is useful to you guys. Are there any initial questions, comments, concerns before I start thinking about closing down, rendering, uploading, and consolidating information? I plan on uploading everything I have in a zip file to both Discord and Canvas. That will include the following documents: my slide deck, my examples, week 14, because I think the lambda calculus stuff is important to have, and Bozzie's documents on OCaml. All of that will get zipped. I plan on taking this video and seeing how fast I can get it uploaded to YouTube. That way I can just post a link. But that also means I probably should get going on uploading it to YouTube so I can just get a link. Otherwise, I will be posting the actual video on at least my section's canvas if YouTube takes too long. Cool. And sorry it wasn't as like polished. I completed this slide deck at 8 o'clock this morning, 9 o'clock this morning, and then I slept for 2 hours. So it's not super polished, but I think between the examples and the information in this slide deck, I think that you guys have a pretty good fighting chance at doing the final without having a breakdown. If this is to be trusted for the content coverage, then you should be fine if everything I've covered today makes sense and you go back over the OCaml stuff and Bozzie's PDF. And double check that you know the answers to the official review stuff because that will also help you just a little bit. Any comments, questions, concerns before I wrap her up? At least anything you guys want in the recording for posterity's sake. Cool. Stop my share. Thank you for listening to me ramble for like an hour and 14 minutes. That's a lot of time that can be done studying. So I hope you have a good rest of your day. I hope that this has helped you in some capacity study. And I wish you the greatest luck on that final and the rest of your finals. Um, but at the end of the day, just remember to breathe. You'll get through it. And as long as you're breathing through it, you won't make mistakes that are more expensive than you want them to be.